The East African Rift is an active continental rift zone in East Africa. The EAR began developing around the onset of the Miocene, 22–25 million years ago. In the past, it was considered to be part of a larger Great Rift Valley that extended north to Asia Minor. The rift is a narrow zone that is a developing divergent tectonic plate boundary, in which the African plate is in the process of splitting into two tectonic plates, called the Somali Plate and the Nubian Plate, at a rate of 6/7 annually. As extension continues, lithospheric rupture will occur within 10 million years, the Somalian Plate will break off, and a new ocean basin will form. Extent: a series of distinct rift basins, the East African Rift System extends over thousands of kilometers. The EAR consists of two main branches. The Eastern Rift Valley includes the main Ethiopian Rift, running eastward from the Afar Triple Junction, which continues south as the Kenyan Rift Valley. The Western Rift Valley includes the Albertine Rift, and farther south, the valley of Lake Malawi. To the north of the Afar Triple Junction, the rift follows one of two paths, west to the Red Sea Rift or east to the Aden Ridge in the Gulf of Aden. The EAR runs from the Afar Triple Junction in the Afar Depression of Ethiopia through eastern Africa, terminating in Mozambique. The EAR transects through Ethiopia, Kenya, Uganda, Rwanda, Burundi, Zambia, Tanzania, Malawi and Mozambique. It also runs offshore of the coast of Mozambique along the Karimba and Leicester Grabens, which are joined by the Davy Ridge, a 2,200 km long relic fracture zone that cuts across the West Somali Basin, straddling the boundary between Tanzania and Mozambique. The Davy Ridge ranges between 30–120 km wide, with a west-facing scarp along the southern half of its length that rises up to 2,300 am above the sea floor. Its movement is concurrent with the EAR. Competing theories on geologic evolution. Over time, many theories have tried to clarify the evolution of the East African Rift. In 1972 it was proposed that the EAR was not caused by tectonic activity, but rather by differences in crustal density. Others proposed an African superplume causing mantle deformation. However, the varying geochemical signatures of a suite of Ethiopian lavas suggest multiple plume sources, at least one of deep mantle origin, and one from within the subcontinental lithosphere. Additionally, the subject of deep-rooted mantle plumes is still a matter of controversy, and therefore cannot be confirmed. The most recent and accepted view is the theory put forth in 2009, that magmatism and plate tectonics have a feedback with one another, controlled by oblique rifting conditions. At that time it was suggested that lithospheric thinning generated volcanic activity, further increasing the magmatic processes at play such as intrusions and numerous small plumes. These processes further thin the lithosphere in concentrated areas, forcing the thinning lithosphere to behave like a mid-ocean ridge. Geologic evolution. Prior to rifting, enormous continental flood basalts erupted on the surface and uplift of the Ethiopian, Somalian, and East African plateaus occurred. The first stage of rifting of the EAR is characterized by rift localization and magmatism along the entire rift zone. Periods of extension alternated with times of relative inactivity. There was also the reactivation of a Precambrian weakness in the crust, a suture zone of multiple cratons, displacement along large boundary faults, and the development of deep asymmetric basins. The second stage of rifting is characterized by the deactivation of large boundary faults, the development of internal fault segments, and the concentration of magmatic activity towards the rifts. Today, the narrow rift segments of the East African Rift System form zones of localized strain. These rifts are the result of the actions of numerous normal faults which are typical of all tectonic rift zones. As aforementioned, voluminous magmatism and continental flood basalts characterize some of the rift segments, while other segments, such as the western branch, have only very small volumes of volcanic rock. Petrology. The African continental crust is generally cool and strong. Many cratons are found throughout the EAR, such as the Tanzania and Cape cratons. The cratons are thick, and have survived for billions of years with little tectonic activity. They are characterized by greenstone belts, tonalites, and other high-grade metamorphic lithologies, The cratons are of significant importance in terms of mineral resources, with major deposits of gold, antimony, iron, chromium and nickel. A large volume of continental flood basalts erupted during the Oligocene, with the majority of the volcanism coinciding with the opening of the Red Sea and the Gulf of Aden approximately 30 ma. The composition of the volcanics are a continuum of ultra-alkaline to thalliatic and felsic rocks. It has been suggested that the diversity of the compositions could be partially explained by different mantle source regions. The EAR also cuts through old sedimentary rocks deposited in ancient basins. Volcanism and seismicity. The East African Rift Zone includes a number of active as well as dormant volcanoes, among them, Mount Kilimanjaro, Mount Kenya, Mount Longonot, Menengai Crater, Mount Karisimbi, Mount Nyiragongo, Mount Meru and Mount Elgon, as well as the crater highlands in Tanzania. Although most of these mountains lie outside of the Rift Valley, the EAR created them. Active volcanoes include Erta-El, Dalafila, and Aldoino Lengai, the former of which is a continuously active basaltic shield volcano in the Afar region of northeastern Ethiopia. When Dalafila erupted in 2008, it was the largest volcanic eruption in Ethiopia in recorded history. The Aldoino Lengai volcano is currently the only active nitrocarbonatite volcano in the world. The magma contains almost no silica, making the flow viscosity extremely low. Its lava fountains crystallize in mid-air then shatter like glass. According to the National Geographic. Approximately 50 volcanic structures in Ethiopia alone have documented activity since the onset of the Holocene. The EAR is the largest seismically active rift system on Earth today. The majority of earthquakes occur near the Afar Depression, with the largest earthquakes typically occurring along or near major border faults. Seismic events in the past century are estimated to have reached a maximum moment magnitude of 7.0. The seismicity trends parallel to the rift system, with a shallow focal depth of 12–15 km beneath the rift axis. Further away from the rift axis, focal depths can reach depths of over 30 km. Focal mechanism solutions strike NE and frequently demonstrate normal dip-slip faults, although left lateral motion is also observed. Discoveries in human evolution. The Rift Valley in East Africa has been a rich source of hominid fossils that allow the study of human evolution. The rapidly eroding highlands quickly filled the valley with sediments, creating a favorable environment for the preservation of remains. The bones of several hominid ancestors of modern humans have been found here, including those of Lucy, a partial Australopithecine skeleton discovered by anthropologist Donald Johanson dating back over 3 million years. Richard and Mary Leakey have done significant work in this region also. More recently, 2 other hominid ancestors have been discovered here, a 10-million-year-old ape called Kororopithecus abyssinicus, found in the Afar Rift in eastern Ethiopia, and Nacalopithecus nakeme, which is also 10 million years old. See also, Baikal Rift Zone, Lake Victoria, Northern Cordilleran Volcanic Province, West Antarctic Rift. References